Moving along now, we're going to learn about the areas of regular polygons and composite figures. And this is the mathematic content standard and the practices. Previously, you have inscribed and circumscribed figures and found the areas of circles. Now you're going to find areas of regular polygons and find areas of composite figures. We have some new vocabulary: the center of a regular polygon, radius of a regular polygon, apothem, central angle of a regular polygon, and composite figure. In this figure, a regular pentagon, ABCDE, is inscribed. That means it's inside circle P. And circle P is circumscribed. That means the circle is on the outside, touching every one of the vertices about the pentagon. The center of a regular polygon and the radius of a regular polygon are also the center and the radius of its circumscribed circle. A segment drawn from the center of a circle, from the center of a regular polygon, perpendicular to the side of the polygon, is called an apothem. Its length is the height of an isosceles triangle that has two radii as legs. So QR and QX and RX are the radii. A central angle of a regular polygon has its vertex at the center of the polygon, and its sides pass through consecutive vertices of the polygon. The measure of each central angle, this would be this angle X, of a regular n-gon is 360 divided by n. So this one has got 5 sides. So the center is at point X. The radius is XR and XQ. Apothem is XN. And the central angle is angle RXQ, or you could entitle it angle QXR. It has 5 sides, so to find the measure of the central angle, we take 360, which is the measure of the entire circle, or the exterior angles of that polygon, divided by the number of sides. So its measure is 72. Time to check your progress. So find the measure of the central angle of this that's inscribed in circle G. So you've got 6 sides. 360 divided by 6 gives you 60. Excellent. You can find the area of any regular n-gon by dividing the polygon into congruent isosceles triangles. This strategy is sometimes called decomposing the polygon into triangles. The top of the table shown is a regular hexagon with a side length of 3 feet and an apothem of 1 7/10 feet. What is the area of the tabletop to the nearest tenth? Since the polygon has 6 sides, the polygon can be divided into 6 congruent isosceles triangles, each with a base of 3 feet and a height of 1 7/10. To find the area of one triangle, again, the area of a triangle is 1/2 the base times height. And so that is the area of one triangle, 2 5/500 square feet. And now that's multiplying by the number of triangles would be 6. So we have 15 3/10 square feet. Okay, time for you to check your progress. Pause the video and solve this problem, then come back and check your answer. Okay, 1, 2, 3, 4, 5, 6. So the central angle is 60. There are 6 sides. Finding the area, 1/2 times 2 times 1 5/10. Get that answer and multiply it times 6. The answer is 9 square feet. The area A of a regular n-gon with side length s is 1/2 the product of the apothem and perimeter. So you can take the apothem, like we did before, times a side and then multiply it by ever how many sides, or we can take 1/2 the apothem times the perimeter. Use the formula for the area of a regular polygon to find the area of a regular hexagon. Round to the nearest tenth. First of all, we find the measure of the central angle, 360 divided by the six sides, so we've got a 60-degree angle. Now we need to find the apothem. Apothem, PS, is the height of isosceles triangle QPR. It bisects angle QPR, so the measurement of angle SPR is equal to 30. It also bisects segment QR, so segment SR is equal to 2 5/10 meters. Triangle PSR is a 30, 60, 90 with a shorter leg that measures 2 5/10 meters. So the longer leg is 2 5/10 times the square root of 3 meters. So we're going to use that formula, 1/2 times the apothem times the perimeter. It is approximately equal to 65 square meters. Okay, find the area of a regular pentagon, round to the nearest tenth. So we know the central angle is 72. Divided in half, that's going to give us 36. So we're going to use trigonometric ratios to find the side length and apothem. We're going to use sine because we have the opposite and the hypotenuse of 36. That will give us the measure of the side length. And cosine of 36 is the adjacent over the hypotenuse. That's going to give us the apothem. Of course, remember, you multiply both sides by 9. Same here. So AB, the entire length, is 2 times 9 sine 36. So the pentagon's perimeter is 5 times 2 times 9 sine 36. And the length of the apothem, there's only one of those, so it's 9 cosine 36 degrees. Substituting those numbers into the formula for the area of polygon, entering into the calculator, we get 192 6/10 square centimeters. Okay, time for you to check your progress. So pause the video and work out the problem, then come back and check your answer. Okay, first of all, I found the measure of the central angle, which would be 60. It's divided in 2. So now I have a 30, 60, 90. Okay, sorry about that. So we've got this divided in 2. So this section, the shorter leg, is going to be 3 7/500. That means that this longer leg, which is going to be opposite the 60, is going to be 3 7/500 times the square root of 3. So if we substitute into the area formula, we're going to have 1/2 times the apothem, which is 3 3/4 times the square root of 3. And it's going to be, the perimeter is 7.5 times 3, so that's times 22.5. That'll give you 73.1. Okay, let's try this one, finding the area of a pentagon. So pause the video, then come back and check your answer. First of all, I found the measure of the central angle, 360 divided by 5 is 72. This one's going to be divided in 2, so we've got a 36-degree angle here. To find the side in the apothem, we're going to have 7 sine of 36, and we're going to have 7 cosine of 36 degrees. So our side is 8 22/100. The apothem is 4 11/100ths. The perimeter is 5 times 2 times 5 66/100ths. Substitute that all into the formula and you get 116 5/10 square meters. Now, a composite figure is a figure that can be separated into regions that are basic figures, such as triangles, rectangles, trapezoids, and circles. To find the area of each basic figure, and then you're going to find the area of each basic figure, and then you're going to use the area addition postulate. So we have here a rectangle, 2 semicircles, and a triangle. So you simply separate it into these different figures and find the area of each one and add them together. Okay, check your progress. So pause the video, find the area of each of these individual sections and add them together and see what you come up with. Well, for the area of the triangle, I got 144, 18 times 8. For the triangle, it's a half times 5 times 8, but there's 2 of them, so then I multiply it by 2. And for the semicircle, it's 1/2 times pi times 9 is the radius, because this side is 18, so radius is 9 squared. When you add them together, I came up with 311 2/10 square feet. The areas of some figures can be found by subtracting the areas of basic figures. So notice here you've got a rectangle within a rectangle. And if you want to find the shaded area, you find the area of each one of these rectangles and simply subtract them from each other. So the area of the shaded figure is 8,500 square feet. So let's try that on your own. Pause the video, find the area of the wall, the shaded wall around the fireplace. Very good. 18 times 10 minus 6 times 4 gives you 156 square feet. Excellent. You are ready to start working on your assignment.